So don't worry. I think I was late, and the point was here the system don't know it taken. Definitely, I'm going to finish it for sure. Yes. So guys, yesterday we are talking about galvanic cell, right? Okay. Yes. Thank you, Sonali. And Anuradha. Okay. Thank you. Thank you so much. And others, please try to connect your, audio. Many people have just connected, but they are not turned on their audios. Okay, I request you to turn on their audios. Okay. Right. Yes. So, yeah, tell me what is the basic, yesterday we are talking about the galvanic cell. So I just want to know from you in this case, okay, from you guys. Okay. So now in this case, where is oxidation is happening? Where is reduction is happening? Before going to start our class today, I would like to know where is oxidation is taking place and where is reduction is taking place. Come on, guys. Tell me from this particular equation, H2S plus Cl2 gives rise to 2HCl plus sulfur. So now I am requesting you that where is oxidation is taking place, where is reduction is taking place. Come on, guys. Come on, everybody. I'm requesting you that please try to answer in the chat box. So we are having, so many people, okay, who joined. Okay, I'm extremely sorry. There is some technical issue, so that's why we couldn't start it as early as possible. So now you can see here. So I'll take you another 10 minutes for sure. Okay, so actually our class is at 5 only, but till 5 I'll take. Okay, so then we can see it later on. But no need to worry about it. But tell me where is oxidation is happening and where is reduction is happening. Now, what is oxidation and what is reduction? I don't want to go from the basics, but you people know oxidation is nothing but there is a increase in the oxidation state. Okay, whereas reduction is nothing but decrease in oxidation state. This is the basic fundamental thing you people know about it. Okay, now. So now tell me where is oxidation is happening and where is reduction is happening in this case. Come on, guys. My dear YouTube friends, try to answer in the chat box also. You can try. Where is oxidation is happening and where is reduction? Guys, can you hear me? Yes, very good. Yes, I got a response. Guys, can you hear me? If yes, please, I'm launching the technical poll. At least answer from there. Right. Yes, I'm audible and I'm visible to you. Right. So my screen is also visible. Right. I'm sleeping. Don't disturb. Okay. Yeah. So yes, many people said that I'm audible only, but why don't you people respond? Okay, try to give your response so that I can feel that you people understand. Yes, very good. So now you can see this is hydrogen is +2 and sulfur is -2. Oxygen, chlorine is 0. Now indirectly you can see here. Here this is hydrogen is becoming +2 and chlorine is becoming -1. Sorry, this is +1 and -1. So we can see chlorine is becoming 0 to -1, okay, and sulfur -2 to 0. So you can see sulfur -2 to 0. So now tell me, here oxidation state increases or decreases? What is the exact tell that here the oxidation state increases or decreases? Come on, guys, tell me in the chat box. Oxidation state increases or decreases? In case of chlorine, in case of sulfur, tell me. 0 to -1 is nothing but what? Increasing at the value, decreasing. Tell me in the chat box. Yeah. So here the oxidation state is decreases. So we can say that the oxidation state is decreases. We can say this is what? This is reduction. So here you can see from -2 to 0, oxidation state is increases. You can say that this is oxidation. This is oxidation. Okay. I hope you will understand. And I told you where there is oxidation, it is acting as a, so where there is oxidation, it is acting as a reducing agent. Okay. It is acting as a reducing agent. Whereas here chlorine is acting as a oxidizing agent. Chlorine is acting as a oxidizing agent. Very good, Sonali Pathak. Very good, Ma. Thank you for your response. Right? So, guys, please do reply in the chat box so that I can feel you people are understanding it. Okay, na? Yes. Second, if you can see 2Na plus H2 gives rise to 2Na. 2Na plus H2 gives rise to 2Na. Okay, so now you can see this is 0 and this is 0. Why, sir? Whenever they are in elemental state, the oxidation state of those particular things are 0. Okay, now. So thank you, guys. So I'm expecting the reply from my YouTube. Okay, so I want response from the YouTube also. Now tell me what is happening for the what is happening for the sodium here, what is happening for the hydrogen. And you can also know that you can also right. Come on, guys, tell me. Okay, very good. So now here you can say sodium is 0 and here you can say sodium will become +1 and hydrogen is 0 and here you can say hydrogen will become -1. So in case of hydrogen, it is becoming H minus 1. In case of sodium, it becoming Na plus. So that is 0 to -1 and 0 to +1. So here it is decreasing in oxidation state. Okay, that's why we are going to call it as what? Decreasing in oxidation state, we are going to call it as a reduction, and increase in oxidation state, we are going to call it as oxidation. So here this is reduction and this is oxidation. So oxidation, the process where oxidation is taking place, we can call it as what? Which reagent it is called as? Tell me in the chat box. Which reagent it is called as? Tell me in the chat box. Which reagent it is called as? Exactly. This is called as reducing agent. Okay. And whereas a reduction is taking place, H2 is acting as oxidizing agent. H2 is acting as oxidizing agent. I hope you people are clear with this. If you are clear, say yes in the chat box. If you are clear with this, please do say yes in the chat box. Yes. Please do say yes in the chat box. Is it clear? Come on, guys, please do a say in the chat box. Only one student is replying. I'm expecting the reply from everyone. What is happening to others? Please do reply in the chat box, guys. I'm requesting you. Thank you, Saugan, Chaube. Very good. Right. So now we started discussing about. So this is what the answers. Okay. So you can also see this one. Later I will share the notes to you. Okay, now. So yeah, so this is what you are going to see. Sodium 0 say plus -1 hydrogen and sodium is becoming +1. So like that we have going to see. And we started discussing about electrochemical cell. Basically in electrochemical cell, it is a device, right? Use it to energy conversion between chemical energy and electricity. Basically we talked about galvanic cell. This is the setup of the galvanic cell, right? And here you may see the chemical energy is going to convert it into electrical energy. Yesterday only I told you chemical energy is going to convert into electrical energy, but it will happen spontaneous यानी अपने आप होना, अपने आप हो जाता है, अपने आप हो जाता है. Just you made the setup, then the electricity will going to produce. Okay, so this is what you people have to know this one, right? And next one we have talked about. Sorry guys. So next we have talked about electrolytic cell. Okay, so that is basically it is used. Okay, it is going to use electrical energy and it will going to produce non-spontaneous redox reaction. So yesterday only I told you what is the meaning of non-spontaneous. Non-spontaneous is nothing but it requires some help. Okay, so best example is ground से पानी को ऊपर लेके जाना, छत के ऊपर पानी ले जाने के लिए जो एनर्जी यूज करते हैं हम, वहां पे मोटर यूज करेंगे. दैट इज एन एक्सटर्नल सोर्स व्हिच इज नथिंग बट वी आर डूइंग नॉन स्पॉन्टेनियस प्रोसेस. वो अपने आप नहीं होता है, उसके लिए कोई एक्सटर्नल का जरूरत है. जैसे यहाँ देखो बैटरी का जरूरत पड़ा, तो इसलिए वी आर गोइंग टू कॉल इट एज नॉन स्पॉन्टेनियस रिएक्शन. Okay, so then we talked about galvanic cell. So basically these are the points we discussed. So it is an electrochemical cell, convert the chemical energy of spontaneous reaction into electrical energy. Okay, so galvanic cell converts the chemical reaction, that is chemical energy, to electricity. So basically there is a Gibbs energy is produced whenever any reactions is taking place. There is a energy, Gibbs energy is going to absorb. This Gibbs energy is utilized as a work. Okay, that work is nothing but electrical work. Whenever there are chemical reactions are occurring, there is a production of Gibbs energy. This production of Gibbs energy is going to utilized as an electrical work. Okay, so next, for example, we have taken zinc in copper sulfate. What we have taken, let's suppose this is the zinc. Okay, this is nothing but my copper sulfate. Okay, this is copper sulfate and this is zinc. Okay, now so the zinc and I have taken a copper sulfate. So what I have observed in this case, okay, zinc in the place of copper sulfate. Okay, what I have observed is there is a potential is observing between these two, copper sulfate and zinc. What is that potential they have observed is 1.1 volt. Whenever they kept zinc inside the copper sulfate, they saw the voltage. Voltage yani that is nothing but potential. Potential nothing but due to the involvement of chemical reactions. You may observe here zinc is reacting with copper sulfate and it is producing copper and becoming as zinc sulfate. Due to this chemical reactions, there is a energy is produced. That energy is utilized as an electrical work. That electrical work is showed in the form of 1.1 volt. Okay, so now basically galvanic cell consists of two parts. One is anode part where it will try to donate the electrons, whereas second part is cathode part where it will try to accept the electrons. Now see here how the exactly it will happen. So now this is zinc. I am saying it as anode. Okay. Now I am talking about Daniel cell. So today this is a Daniel cell. Daniel cell is an example of galvanic cell. what this Daniel cell will do? Daniel cell is using zinc as anode, okay, and copper as cathode. Okay, this is what they are doing to do. So whenever he taken zinc and he kept in the zinc nitrate solution, he taken a zinc electrode and he kept in the zinc nitrate solution. And later on, okay, so he started observe that something is going to happen. That means the zinc is going to lose its electron. So this zinc is going to lose its electron by producing the Zn plus 2 ions inside the solution. So whenever he kept the zinc rod inside the copper, inside the zinc nitrate solution, he started that zinc is losing 2 electrons and producing 2 electrons. That is, it is going to become Zn plus 2 and losing 2 electrons. Now tell me guys, what is the meaning of this one? From 0 to plus 2 state. What is happening here? Anode, whether it is happening oxidation or reduction. Tell me in the chat box. Anode, whether it is taking place oxidation or reduction. Come on, guys, you people easily tell this. You can easily say this one. Come on. Yes, very good, Sonali. That is correct. Okay, what exactly happening in this case? Where is zinc is going to lose 2 electrons. Zinc is going to lose 2 electrons and producing Zn plus ions inside the solution. So from 0 to plus 2 state, that is increasing oxidation state. You can also say here oxidation is occurring. Clear? So next one, what else we can see here is, so later he taken copper sulfate or copper nitrate solution and he kept copper metal here. He kept copper metal here. Okay. Whenever he kept the copper metal and he connected both of them. Okay. When he connected both of them, he connected both of them by using a salt bridge. By using a salt bridge, he connected, right? Yeah. So now you can see here, before using the salt bridge, he kept a voltmeter here. Why he is using the voltmeter? He want to know that where the deflection is taking place. If the deflection is taking place, then he can decide that there is something electrical work is produced. So these are chemical reaction where zinc is losing 2 electrons, right? Whereas copper ions is going to consume 2 electrons and becoming copper. So there is a involvement of electrons, right? So due to the involvement of electrons, you may see here, these electrons are flowing in this direction. Electrons are flowing in this direction. So definitely current will flow. Current will flow in this direction. Okay, opposite direction towards the direction of electrons. Clear? Huh? Okay, so that is what you people need to remember. So one thing he observed that whenever they connected with the voltmeter, he saw the deflection inside the voltmeter. He saw the deflection. He saw the deflection inside the voltmeter. So he decided that something is happening here. So I am using chemicals. These chemicals are losing some electrons on the surface of the metallic rod. These electrons are traveling in this direction. These electrons are traveling in this direction. Whenever these electrons are traveling in the opposite direction, current is flowing. Whenever the electrons are traveling in this direction, okay, that current is flowing in opposite direction. That is Zn is gives rise to Zn plus 2. Okay, whereas these two electrons, so copper sulfate which is present inside, is consuming the 2 electrons and become copper solid. Okay. So whenever he observe the net reaction, whenever he write the net reaction, this is equation 1 and this is equation 2. He observed that zinc is going to become Zn plus 2 copper sulfate, where which is present has, that is copper nitrate. Inside the copper nitrate, copper 2 ions are consuming 2 electrons and becoming copper. So here number of electrons involving is 2 electrons. Okay, 2 electrons are involving during this particular process. So to complete this particular cell, he kept a salt bridge. Okay, to complete this particular cell, he kept a salt bridge. We are going to study about this one first, right? So after some time, we observed that this is the size of the anode and this is the size of the cathode. Okay, this is the size of the anode and this is the size of the anode. So to remember this one, we are going to give you a trick that is called as loan. What is meaning by loan, sir? Loan is nothing but left oxidation anode negative. Sir, what is this meaning exactly? Left oxidation anode negative. Left oxidation anode negative. What is going to become here? What is left oxidation anode negative? So left side, we are having a anode. This anode is doing oxidation. What is the charge present on this anode? That is a negative charge. Why, sir? It is losing zinc ions and having electrons on its surface. That makes it, that particular thing makes, okay, this particular anode as negative. Whereas right side one, how do you call it as? I am calling it as RRCP. What is the meaning of RRCP? That is Rajasthan Royals won first IPL Cup. Rajasthan Royals won the first IPL Cup. So what is the meaning of RRCP? RR is Rajasthan, CP is nothing but Cup. Okay, Rajasthan Royals won first IPL Cup. That means right reduction cathode. What is the charge? That is positive. Okay, right reduction cathode positive. You people need to remember this one. First one is lone, second one is RRCP. Lone is nothing but left oxidation anode negative, right reduction cathode positive. I hope you people understand this one. If you are clear with this, please do reply in the chat box. If you are clear with this, please do reply in the chat box. Come on. Yes, very good, very good. Thank you so much. Yes. So, right. So next one, just now only I talked about anode. Anode, what is happening at anode? Anode, we have seen oxidation and it is releases the electrons. So the net reaction of oxidation, it's look like this. So in case of zinc, we just saw Zn plus 2 electrons. This now we have saw it. Okay. So the anode is also called as oxidation half cell. Whatever the reactions occurring at the anode, we are going to call it as oxidation half cell reaction. And we also see that charge is negative. Okay, and during oxidation, positively charged ions would enter into the electrolyte solution. Just now I told you zinc is going to lose Zn plus 2 electrons. Yani Zn plus 2 electrons is going to produce inside the electrolytic solution. Okay, so first best example is Daniel cell. Just now I have discussed. Okay, Daniel cell, we applied zinc rod inside the zinc sulfate. So this is the equation we have seen. And later on, we talked about cathode. Cathode is nothing but it receives the electrons, or we can also say it accepts the electrons through the external circuit. Okay, so we know that cathode, it is reduction, RRCP, that is right reduction cathode positive. Right reduction cathode positive. Okay, now this is what you are going to see here. Okay, so that's it, guys. So now you can see again, cathode is called as reduction of cell. Simultaneously, where you are going to call it as oxidation of cell, here you are going to call it as a reduction of cell, right? And cathode is a positive where there is a polarity is present, right? Okay, cathode is having a positive charge. The reason because you know all the copper ions will going to be present on the surface of the copper cathode. Copper cathode के ऊपर copper cathode के ऊपर all the copper ions are going to present. So that's why we are going to call it as copper cathode. Next, during reduction, okay, positively charged metal ions get reduced, okay, and deposited on the electrode surface. Just now I told you the point. Okay, another is in Daniel cell only we have seen. In Daniel cell we have seen. Okay, I have given the definition of metallic rod also, which is nothing but electrode. Okay, this we have discussed. So this is the net cell reaction. Okay, if you see the this one is oxidation half cell and another one is reduction half cell. Okay, so galvanic cell is consists of oxidation half cell and reduction half cell. And I told you oxidation occurs at anode, reduction occurs at cathode. Okay, and there is a salt bridge is present here. There is a salt bridge is present. This salt bridge is used to maintain the electrical neutrality, and we will talk about the main functions of the salt bridge also. So this is oxidation of cell reaction. This is reduction of cell reaction. If you write the net cell reaction, you are going to get the overall cell reaction. That is this one. Okay. So what is the functions of salt bridge? Salt bridge is nothing but it is used to maintain the neutrality. As the cell reaction proceeds, anode half cell has the positive charge ion. Matlab, it is going to Zn plus concentration will increases, whereas on the other side, Cu plus 2 concentration is going to decrease. So if it is continuously happened, after some time, zinc nitrate, whatever the nitrate you have taken, it is going to be vanished. Where whatever the copper sulfate you have taken, you are going to be vanished. So after some time, the reaction may stop. So in order to fulfill this gap, salt bridge is used to maintain the electrical neutrality. So we can say that to maintain the electrical neutrality, they are going to use the salt bridge. Basically, salt bridge are KNO3 and KCl are used, which is a agar solution where gelatin is mixed with KCl along with KNO3. So both K plus and NO3 minus or K plus and Cl minus have same velocity, or we can also say that ionic mobility. Ionic mobility will be same. So they will go same side. That means K plus will go where there is a less positive charge. O minus will go where there is a less negative charge. Okay. So in case if you see in this case, in case if you see, okay, in case you can see here, so K plus will go towards the reduction half cell time, and for the whereas to maintain the electrical neutrality, okay, K plus will go towards this side, and in this side NO3 minus or Cl minus will go. Okay, so these are the important points of the salt bridge and everything. So today just I'm going to talk about this one. So basically we just talked about galvanic cell. Okay, galvanic cell is using the chemical energy and produces electrical energy, and we have seen two reactions. One is oxidation half cell reaction, and next one is reduction half cell reaction. So in oxidation half cell reaction, what is happening in oxidation half cell reaction? We have observed it is occurs at anode, and reduction half cell reaction is occurs at cathode. And this will be present at the left side, and this will be present at the right side. Okay, now the charge present here is negative, the charge present here is positive. So to remember this one, I given a trick called lone, that is left oxidation, anode negative, and I have given a short trick RRCP, that is right reduction cathode positive. We have mentioned these points. So now how do you represent this one? Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. How do you represent this one? So zinc is going to become Zn plus 2. So I'm going to represent like this. Zinc is going to become Zn plus 2. Whereas Cu plus 2 is going to become Cu. That is Cu plus 2 is going to become Cu. So to connect these two, to connect, I am using two lines. These two lines are indicating the salt bridge. These two lines are indicating the salt bridge. How it exactly look? Zn plus 2, salt bridge, Cu plus 2, Cu. So the line is indicating the phase difference. Like this is the solid phase, and this is aqueous phase, and this is aqueous phase, and this is solid phase. And here this is nothing but salt bridge. So this is the cell representation. Okay, I hope you people understand this one. Okay, yes. So I hope you people are clear with this. If you are clear with this, please let me know through the chat box. If you are clear with this, please let me know through the chat box. Okay. Right? Very good. Thank you. So now I am going to tell you this one. Yes. Yeah. So now try to answer this one. Yeah, try to answer this one. Daniel cell converts dash energy to dash energy. Come on, guys. Daniel cell converts dash energy to dash energy. Which energy to which energy? Come on, try to answer in the chat box. Come on, you have to tell this. Right, I got a response. Yes, chemical to electrical. One is chemical and another one is electrical. Here, right. So in Daniel cell, the reduction half cell reaction occurs on the dash electrode. Daniel cell, the reduction half cell reaction occurs on the dash electrode. Yes, occurs at cathode. Okay, for that I told you RRCP. Okay, that is right reduction cathode positive. So in galvanic half cell, in which oxidation takes place if the reduction at cathode, and whatever this one, this is at. Okay, this is answer, this is not the answer. Very good. So write the, this is homework for you guys. Yes, this is homework for you. What about here PT, sir? PT is nothing but electrode. Okay. So this is homework for you. That is Cl minus is going to become Cl2 and Br2 is going to become Br minus. So you need to write the oxidation of cell reaction and simultaneously you need to write the reduction half cell reaction. Clear everybody? I hope everybody clear with this. I hope everybody clear with this. If you are clear with this, please mention in the chat box. If you are clear with this, please mention in the chat. Right? Yeah. So that's it, guys. So thank you so much for joining the class. And I'm sorry for the technical issues. And it was too much big for me so that I couldn't make aware of it. So later on, I realized that we are having class and then I have taken. I think we missed it 20 minutes class. Don't worry, I'll cover in the coming classes. Okay. So thank you so much for your patience and your responses in the chat box. Okay. That's it, guys. See you on Monday. Bye bye.